Okay, now welcome. Let's look at, apart from the first principle, we have another rule that we can also use to solve differentiation. But they are numerous. Okay, so we are going to take them one by one. You done with the first principle. So in the exams, you'll be asked to use the first principle. That's where you use that formula. But if you are not asked to use the first principle, then you have another way of doing it. So the first one you're going to look at is the power rule. Power rule. What do you mean by the power rule? Let's take this for instance. If y equals x to the power n, where n is an integer, okay? Now, if you want to find dy dx of this, you don't say dy over dx, it's dy dx. Then what you do is that you take this integer and you multiply it by the x here. So you become n times x. Is that okay? Then you bring the power again. Then you reduce that power by 1. So in conclusion, it becomes something like this. N x to the power n minus 1. Are you seeing it? Now, if let's say we have y equals a x to the power n, so I'm going to have dy dx to be equals to n times ax, okay, multiplied by n to the power negative 1, x to the power n minus what? 1. So this is how it is done. That's the power rule. So let's look at examples. Okay, so now these are the examples. So let's see how we can solve them. So the first one is y equals x to the power 5. So if I'm to differentiate, it becomes dy dx. The rule is saying that you should multiply this 5 by the x, so that becomes 5x. Then reduce this 5 by 1, so it will be 5 minus 1. 5 minus 1 is 4. So here will be what? 4. So that's the answer to the I. Is that okay? Now let's look at the I. Y equals negative 3x squared. So dy dx is going to be negative 2 times negative 3 will be negative 6x to the power 1. If I subtract 1 from 2, I'll get 1. But normally you don't write it. Is that okay? Good. So that is the two. Let's look at the third one. Y equals 5x. So dy dx equals 5. Why are we saying 5? Remember, this one is power 1. The x is to the power 1, but we don't write. So if it is power 1, I'll multiply 1 by 5. I'll get 5, right? Then I'll subtract 1, 5x, okay? Then I'll reduce it by 1. So 1 minus 1, you see that I'm going to have 5x to the power 0. X to the power 0 is 1. So we have 5 times 1, which is still 5. So what it means is that if I differentiate this, I'll get what? 5. So if you have 10x, if you differentiate, you have 10. 11x, if you differentiate, you have 11. That's how it is done. Now let's move to the IV. Y equals 8 over s squared. So this one, before you solve, you have to do this. Y equals 8x to the power negative 2. I hope you know this thing. Let me solve it here. So we have y equals 8 to the power x to the power 8 times x to the power negative 2. From indices, we learned indices. And we said that if I have 8 to the power negative n, can be written as a 1 over 8 to the power n. So something like this. So I can bring this one to become like this. So that's what I've done. Once I'm done with this, the dy dx becomes simple for me to find. So the negative 2 multiplied this, that will be negative 16x to the power. Now if I subtract 1 from this, it becomes negative 3. Okay, so here will be negative what? 3. Because the thing was given to you in the form of fraction, you leave your final answer as negative 6 over x cubed. Is that okay? It's negative here, so when it becomes x cubed. All right. Let me look at. There's one. You will do this, okay, and leave your answer in the comment section. That one it will behave like this. But let's see. Let's say if I have y equals root x. That was not part of the example, so I want to show you something. See, this is root x. This root x can be written as x to the power half. So anytime you see a root is power half. So when I want to differentiate this, I'm going to have dy dx equals the half multiplying the x to the power half minus 1. Half minus 1 is negative half. So we have half x to the power negative half. Is that okay? So this is how we differentiate. So this one, where you can change this one to the x to the power half, you bring it to become x to the power negative half, then you start the differentiation process. Now let me look at the last one, which is the vi. It's very important. Vi, y equals 7. Now this 7 is a constant. Anytime you differentiate a constant, we get 0. Okay, why are we getting 0? Because this 7 here is also having x attached to it, but it is power 0. We all know that x to the power 0 is 1. So 1 times 7 is 2. So when we have a constant, the constant is having x attached to it, just that it's power 0. So anytime you are asked to differentiate a constant, you get what? 0. All right. Now you can use the first principle to prove that why that one is 0. So let's see. So we are going to use the first principle to prove why the differential or the derivative of a constant is 0. So from the first principle, we know that dy dx is always equal to the limit as h approaches 0 of x plus h minus f at x, all divided by h. So now let the function f at x to be equals to c, okay? Where the c is constant. So the c is constant, okay? But remember, this constant, as I said, is having power 0 here. So you have it like x to the power 0. So x to the power 0 is 1 times c will give you the constant. Okay. So here, if I want f at x plus h, it comes to be c bracket open x plus h to the power 0. Now, normally the x plus h takes the position of where the x is. This is just a constant. It's like when I have 4x, okay? The 4 is constant. So if I want to write, so if this is f at x equals 4x, if I want to write f at x plus h, this is a constant, so that one will be out. Then the x plus h will take the position of the x, which will become x plus h here. So that's what I've just done there. So now I'm going to substitute this into the formula. So dy dx equals the limits as h approaches 0. F at x plus h is c bracket open x plus h all to the power 0 minus f at x is c x to the power 0. And remember, all this is over h. Now, x plus h to the power 0 is 1. For any number except 0 is up to the power 0 is 1. And this one will give you 1, meaning that here I'm going to have dy dx to be the limit as h approaches 0, c minus c over h. So my dy dx will be equal to the limits as h approaches 0, 0 over h. And 0 over any non-zero number is 0. So here the answer will be what? 0. So that is why anytime you differentiate a constant, you get 0. Is that okay? Now let's move to another topic.